Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
My Weird Prompts is an AI-generated podcast produced by Daniel Rosehill, a verified human with documentation to prove it. While every effort is made to ensure our AI hosts draw from credible sources and run on cutting-edge models, they do occasionally make things up with alarming confidence. As with everything in life, and especially this podcast, treat all claims as spurious until confirmed to be not. Daniel, Herman and Corn accept no responsibility for any decisions made based on the confident ramblings of our artificial presenters. Now, today's episode.
Hey Herman and Corn, so very much enjoying listening to your response to my question about the Internet of Things and how that can be done. I've mentioned that I've been using Home Assistant for a number of years. It can be a very brittle project, and I've often wondered how building automation is done in contexts where that kind of, extreme brittleness is absolutely unacceptable. And I mentioned airports and museums just as examples of buildings that are have a very low threshold, especially airports where you can't have stuff like a random update bricking the lighting control and the airport being plunged into darkness. We would see headlines all over the world if that was happening regularly. So in the course of that, we were talking about networking and networks, which is a really on the surface dry topic, but I think actually there's a lot of interesting things to know about networking. We're talking about Zigbee, LoRaWAN, and MQTT and all these different protocols for IoT. It brought back to mind, I'm not sure why this episode made me think of it, but years ago, my first office job here in Israel was working at an industrial IoT company. This was actually before I'd even gotten into home automation myself, and I even remember writing about technology like Zigbee and LoRaWAN back in the day. And I had an interesting chat at one point with the CTO, who mentioned that it's possible to transmit Wi-Fi over miles. Now, I think this was just kind of like a throwaway comment. We were talking about what different networks can do, and he had an interesting background, like many people in the that you encounter in the high-tech world in Israel, in the Israeli signals intelligence world. So, it was kind of like a little morsel of information, but it really got me thinking, hang on a second. Wi-Fi, we think about Wi-Fi as something we put up in our home, and, we know that it's challenging to get Wi-Fi to cover your average home network. There is, of course, mesh technology, which has, for a renter like me, it's just about the best that we can do because we can't run Ethernet around the property. And even then, it's kind of very limited. I was measuring my home mesh network the other day. I use Ethernet at my computer. And the drop-off is actually about fourfold. In other words, the download speed we get in the living room is 4 times lower. And that's just transmitting over 20 meters and a wall in between. So it surprised me, the concept that Wi-Fi could actually be scaled up to broadcast over miles was kind of really got me thinking. Now, when I was looking into this in our old place that we used to live in, this was before fiber internet rolled out in Israel. And we had terrible networking that was kind of the bane of my remote work life. And I exhausted a lot of effort in trying to solve this, as I do. One of them was connection bonding, pairing together a DSL network with a cellular network, like a 4G network. And that kind of worked, at least got us over the speed bumps where our internet would regularly drop out for like a couple of hours. But it didn't do much for the actual speed, truth be told. Now, in the course of all this kind of exploring what the options were, I really did find it interesting to learn about the various ways in which we take for granted in urban environments in developed countries that, you're going to have ISPs and they just show up at your door and they rig you up. And in some parts of the world, especially remote communities, it's really not that easy. And the ISPs are sometimes even community driven. They're not these kind of corporate monoliths. The tech more tech motivated, tech savvy people in the community actually sort of bond together and form their own local ISP. It's actually pretty wholesome and pretty interesting. And to do this, they frequently use stuff like cellular network being beamed point to point from one place where it has good network reception to another part, maybe their village, let's say. And then this ISP will rebroadcast this. Now, here's what I'd like to ask. I was looking at this thing and I was reading about point-to-point internet, and it got me thinking, hang on a second. Let's just play with this in today's episode as purely a hypothetical. TP-Link will sell you a PTP, a point-to-point relay for $100 or so. And let's say that I was living in one neighborhood in a city, and I was determined, and I had a house in a second neighborhood. And I wanted to just use one internet connection. I didn't want to pay for 2 subscriptions. This is clearly ridiculous because the cost of the networking equipment would dwarf the cost of a second ISP subscription. But again, let's just use this as a hypothetical. And I decided that I wanted to set up a series of point-to-point nodes to take internet from house 1, bring it over to house 2, and set it up there. Or on a slightly less ridiculous level of scale, we used to have a guy living next to us who had a kind of B&B property, and he lived across the road from his B&B. And he'd go over there a few times a day to check up on guests, whatever. So let's take this example. The guy wants to set up internet at home, and he's going to broadcast the network across the street, about 30 meters, over to his commercial property, and run the network that way. So my question is this. How long in either case would it be before a knock on the door came from someone who's wondering why on earth you set up these unauthorized transmission stations? But the law aside, would it work? Or would the latency of these multiple hops just degrade the connectivity? Love to hear your thoughts on all these random thoughts about networking. It's always interesting to delve into the possibilities of what we can do with the technologies at our disposal.
Hey everyone, welcome back to my Weird Prompts. I am Corn, and I am so glad you are tuning in with us today here in chilly but beautiful Jerusalem. I am joined, as always, by my brother,
Herman Poppleberry, at your service. It is good to be here, Corn. We have a really fascinating set of questions to dive into today. Our housemate and friend Daniel sent over a voice prompt that honestly touches on some of the things I have been obsessing over lately. It is about the hidden systems that keep our world running, and the links people will go to for a better internet connection.
Yeah, Daniel was asking about something I have definitely noticed. You know how our smart lights sometimes just decide they do not want to talk to the bridge anymore, or how an update on your phone can suddenly make the whole house system go wonky. Daniel was wondering how places like airports or museums handle this. Because if the lights go out at an international airport because of a bad firmware update, that is not just a nuisance, it is a global news story.
Exactly. It is the difference between consumer-grade technology and industrial-grade automation. And being a donkey who spends way too much time reading technical manuals, I can tell you that the world of industrial automation is a completely different beast. It is built on a philosophy of permanence and predictability that we just do not see in the stuff we buy at the store.
I remember you saying once that most home automation is basically held together with digital duct tape. Is that what Daniel means by brittleness?
Precisely. Most home systems are built for convenience and low cost. They rely on your home Wi-Fi, which is already crowded with phones and laptops, and they often depend on a cloud server somewhere else in the world. If your internet goes down, or the company's server has a hiccup, your light switch stops working. In an airport, that is unacceptable. Today, we are going to look at the protocols and the hardware that make these big buildings rock solid.
And then we are going to get into the second part of Daniel's prompt, which is some real MacGyver-level networking. He was asking about point-to-point internet. Like, if you wanted to share a single connection between 2 different properties using a series of nodes. I am picturing someone setting up antennas on rooftops to beam Wi-Fi across the city.
It is more common than you think, Corn, especially in places where the big internet providers refuse to run cables. But Daniel's specific question about latency and multiple hops is the real brain teaser. Does the signal get tired the more times it has to jump from one antenna to another? We will break down the physics of that in the second half.
I love it. Let us start with the big buildings, though. When I walk into an airport, I see thousands of lights, moving walkways, climate control systems, and security sensors. Are they using some kind of superpowered version of what we have at home?
Not really. They actually use systems that predate the modern smart home by decades, but they have been refined to be nearly indestructible. In the industrial world, the gold standard is something called a programmable logic controller, or PLC. Unlike the little chips in our smart bulbs, a PLC is a ruggedized computer designed specifically for high reliability in harsh environments.
Ruggedized? Like, you could drop it or something?
It is built to handle heat, vibration, and electrical noise that would fry a normal computer. But more importantly, the software it runs is deterministic.
That sounds like exactly what our house needs. Why do we not just have a PLC for our kitchen lights?
Well, for one, they are expensive. And two, they are not exactly user-friendly. You do not just download an app and tap a button to set them up. You have to program them using something called ladder logic, which looks more like an electrical circuit diagram than modern code. But the benefit is that they do not need the internet to function. They are local. They are air-gapped from the outside world.
So when Daniel talks about the brittleness of home systems, he is talking about all those layers of failure we have. The Wi-Fi, the cloud, the app updates. An airport bypasses all of that by using dedicated wires and protocols like Bacnet or LawnWorks.
Right. Bacnet is a huge one. It stands for Building Automation and Control Networks. It is a communication protocol that allows devices from different manufacturers to talk to each other. So the air conditioning system from one company can talk to the lighting system from another company without needing a translator. And it all happens over dedicated physical cables, usually something called RS485 or Industrial Ethernet.
Wait, so they're still using cables? In 2025? I thought everything was going wireless.
Wireless is getting better, but in a museum or an airport, a cable is still king. A cable cannot be jammed by a microwave or interfered with by 1,000 passengers all turning on their hotspots at once. When you are protecting $1 billion worth of art in a museum, you want to know that the humidity sensor is going to report back every single second without fail.
That makes sense. I guess being a sloth, I appreciate things that are slow, steady, and reliable. But what about when things do need to be updated? Does someone have to go around with a laptop and plug into every light pole?
They have centralized management, but the updates are handled with extreme caution. In an industrial setting, they use a sandbox. They test the update on a mirror of the system first. They do not just push it out to the whole airport at once. They might update one terminal at 3 a.m. and monitor it for a week before doing the rest. It is a culture of risk aversion.
It sounds like a lot of work, but I guess that is why my flight usually takes off in a well-lit terminal. Okay, so that covers the big buildings. But Daniel's other question was about a much more personal kind of networking. Point-to-point internet.
Yes, this is where it gets really fun. Daniel mentioned his first job at an industrial Internet of Things company and talking to a CTO about transmitting Wi-Fi over miles. This is a real thing. It is often called a wireless bridge.
And Daniel's hypothetical was about sharing one connection between two properties, maybe his house and another one nearby. He was worried about the latency from multiple hops. If the signal has to go from house A to a pole, then to another pole, then to house B, does it slow down?
That is the big question. Let us think about what a hop actually is. In networking, a hop is when a packet of data moves from one device to the next. Every time a packet arrives at a node, the node has to receive it, process where it needs to go, and then retransmit it. That takes time.
Like a relay race. If you have more runners, it takes longer to get to the finish line because of the handoffs.
That is a perfect analogy, Corn, but the question is, how much time? In the old days of mesh networking, every hop could cut your speed in half because the radio had to use the same frequency to listen and then talk. It was like trying to have a conversation where you can only speak after the other person finished, and you have to repeat everything they said to the next person.
That sounds exhausting and very slow.
It was, but modern point-to-point hardware, like the stuff companies like Ubiquiti or Microtik make, is much smarter. They use multiple radios and directional antennas. Instead of a signal that goes out in all directions like a light bulb, these antennas are like lasers. They focus all the energy into a narrow beam pointed exactly at the next node.
So it is a literal beam of internet.
Pretty much. And because the beam is so focused, it can travel miles. I have seen setups where people get high-speed internet across 20 or 30 miles of open space. But Daniel's concern about latency is still valid. Even with the best gear, every hop adds a tiny bit of delay. Usually, it is less than 1 or 2 milliseconds per hop.
1 or 2 milliseconds? That sounds like nothing.
For browsing the web, it is nothing. You would never notice. But if you are a professional gamer or doing high-frequency trading, those milliseconds add up. However, for Daniel's hypothetical neighbor who wants to share a connection across the street, the latency would be virtually imperceptible. The bigger issue would actually be signal interference and something called the Fresnel zone.
The Fresnel zone? That sounds like a French bakery.
I wish. No, the Fresnel zone is an elliptical area around the line of sight between two antennas. Even if you can see the other antenna with your eyes, if there are trees or buildings partially blocking that elliptical zone, the signal will bounce around and cancel itself out. It is one of the most common reasons these point-to-point links fail.
Fascinating. So you have to be really precise with where you point these things.
Exactly. It is a bit of an art form. But before we get deeper into the physics of multiple hops and the legality of beaming Wi-Fi across neighborhoods, let us take a quick break for our sponsors.
Idea. We will be right back.
Are you tired of your neighbors knowing exactly what you are doing online? Are you worried that the government is reading your thoughts through your router? Introducing the Signal Sweeper 3000. The Signal Sweeper is a revolutionary lead-lined umbrella designed to catch stray Wi-Fi signals before they can escape your property. Simply open the Signal Sweeper in your living room and feel the peace of mind as your internet speed drops to zero, ensuring total privacy drops to zero, ensuring total privacy. It also functions as a very heavy, very dangerous hat. We do not offer a warranty, and we are not responsible for neck strain or sudden isolation. The Signal Sweeper 3000. Because if you cannot see the internet cannot see you. Buy now.
All right, thanks, Larry. I am not sure I would recommend a lead umbrella for anyone's neck health, but he certainly has enthusiasm.
He really does. Anyway, back to Daniel's prompt. We were talking about point-to-point internet and the idea of multiple hops. Herman, you said the latency is actually quite low with modern gear. So, if Daniel set up 5 nodes to get internet to a remote property, it would actually work.
Theoretically, yes. If each hop adds 2 milliseconds, 5 hops only adds 10 milliseconds of latency. To put that in perspective, the time it takes for a human to blink is about 100 to 400 milliseconds. So 10 milliseconds is almost nothing. You could stream high-definition video, hop on a video call, and never know the difference.
So why do more people not do this? If I can just beam my internet to my friend's house 3 miles away, why are we all paying separate bills?
Well, that brings us to the second part of Daniel's question. How long before a knock on the door comes from someone wondering why you have an unauthorized transmission station?
Right, the legality. Is it illegal to beam Wi-Fi to your neighbor?
It is a gray area, but it usually comes down to 2 things: the terms of service of your internet provider and the regulations of the Federal Communications Commission or the local equivalent here in Israel. Most internet contracts have a clause that says you cannot reshare the connection outside of your primary residence. If they catch you, they can just cut your service.
But would the government actually show up?
Probably not for a simple Wi-Fi bridge. Most point-to-point gear operates in the 5 GHz or 60 GHz bands, which are unlicensed. That means anyone can use them as long as they follow the rules for power output. If you start using massive amplifiers and interfering with weather radar or emergency services, then yes, someone in a very official-looking van will definitely come knocking.
So Daniel's friend with a bed and breakfast property across the road is probably safe.
Most likely. In fact, many people use this exact technology to connect barns, guest houses, or remote offices on their own land. It is often much cheaper than digging a trench and laying fiber optic cable, which can cost thousands of dollars just for a few hundred feet.
I remember Daniel mentioned that in some parts of the world, especially in remote communities, the internet providers are actually community-driven. They use these point-to-point links to build their own local networks.
That is one of the most inspiring parts of networking technology. There are places in mountains or rural plains where big companies refuse to go because it is not profitable. So the locals get together, buy some high-end wireless gear, and build a mesh. They might have one single high-speed fiber connection at a school or a library, and then they beam it out to every house in the village using these hops.
That is amazing. It is like a digital barn raising. But what happens if one house in the middle of the chain turns off their router? Does the whole village lose internet?
That is the big risk with a linear chain of hops. If any link in the chain breaks, everything beyond it goes dark. That is why professional community networks use a mesh topology. Instead of a straight line, they build a web. Every house might be connected to 2 or 3 other houses. If one goes down, the data just finds another path.
Like a detour on a road trip.
Exactly. It adds a bit of complexity to the routing, but it makes the network much more resilient. This actually brings us back to Daniel's first point about airports. Resilience is the goal. In an airport, they have redundant cables. If one gets cut by a construction crew, the system automatically switches to the backup.
It is interesting how the goals are the same, whether you are an airport manager or a guy trying to get Wi-Fi to his guest house. You want it to work, and you want it to keep working even when things go wrong.
And that is the heart of the matter. The brittleness Daniel talked about is really just a lack of redundancy and a reliance on things we do not control. When you build your own point-to-point link, or when an airport builds a dedicated lighting network, they are taking control of the infrastructure.
So, for the regular people listening, what are the practical takeaways here? If someone wants to make their home less brittle, what can they do without hiring an industrial engineer?
The first step is to look for local control. When you buy smart home devices, look for ones that use protocols like Zigbee, Z-Wave, or the newer Matter standard. These are designed to work locally within your house. If your internet goes out, your light switches should still work. Avoid devices that are cloud only, where every command has to travel to a server in another country just to turn on a bulb 3 feet away from you.
That is a great tip. I know we've been moving our house toward that. It makes a huge difference in response time, too. No more waiting for the cloud to wake up.
And for the networking side, if you have a big property and your Wi-Fi does not reach the garage, do not just buy a cheap extender. Look into a dedicated wireless bridge. It is a bit more work to set up, but the stability and speed will be vastly superior. Just make sure you have a clear line of sight.
And watch out for the Fresnel zone. I am going to remember that one.
It is a good term to drop at parties if you want people to think you are a networking genius or if you want them to stop talking to you. It works both ways.
Well, I think we have covered a lot of ground today. From the heavy-duty systems at the airport to beaming internet across the street. It is all about making the invisible visible, right?
It really is. Most people never think about the protocols running behind their walls until they stop working. But understanding how they work gives you a lot of power to build a more reliable life.
I feel a lot smarter now. Thanks for breaking all that down, Herman Poppleberry. And thanks to Daniel for the great prompt. It really got us thinking.
It was a pleasure. It is always fun to nerd out on this stuff. I am already looking forward to whatever Daniel sends us next week.
Me too. For everyone listening, thanks for joining us on My Weird Prompts. We hope you learned something useful today, or at least found the idea of a lead-lined umbrella as funny as we did.
Please do not actually buy a lead-lined umbrella.
Yes, please do not. You can find us on Spotify and at our website, myweirdprompts.com. We have an RSS feed there for subscribers, and if you have a weird prompt of your own, there is a contact form where you can get in touch with us. We love hearing from you.
We really do. And remember, the year is 2025, and the technology is only getting more interesting. We will see you in 2026 for our next episode.
Thanks for listening to My Weird Prompts. Stay curious, and we will talk to you soon. Bye.
Bye-bye, everyone.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.